All right, everyone. It is 10 o'clock or close enough to it, so we're going to go ahead and get started. Really appreciate everyone joining us today. I know, obviously, got the long weekend ahead of us, so really appreciate you taking some time today to sit with us. I have Don Cameron with me from Yaskawa. We are going to discuss the HV600 VFD and the compatibilities that it has to meet the requirements for Denver fire. So Don, I'll go ahead and pass this over to you and let you get started.
Yeah, appreciate that. Thanks, Jeff. Yeah, so my name is Don Cameron. I'm the industry segment manager for HVAC drives. I've been in the drives business for more than a quarter century. So I've got a little bit of experience with Yaskawa for about a year. A long time ago, I worked for Yaskawa as a motion control guy, but that was a lifetime ago. So we'll dive right into it here about fireman's override or VFDs, and some of this may be repeat information for some of you, but for those that it's brand new, it's important to cover all the bases. So what to expect from variable frequency drives when it comes to fire mode. So really there's a important point we'll talk about in relation to, do drives need to be UL 864? We'll talk about system function requirements. And the most important thing to learn today is that whatever it is that you're trying to do, whatever the inspector wants from your installation, VFDs in general are flexible enough to almost meet every requirement. It's just enough IO being on board on the drive, and then being able to program that drive so that it can do what it is that is expected. So the good news is when you're incorporating a drive, especially a Yaskawa drive, it's very easy to make it work in that installation, in that application. Whatever that fire inspector wants, we can make it work. We just have to know what it is they want. And if you don't know what a drive is a motor controller, and it modulates the motor speed of for fans and pumps. And that's how we save energy, but also it's also in a smoke or fire situation, how we can expedite the exit of smoke and create positive or negative pressure. So what does a drive do or a VFD do in a fire control panel situation? So when the drive receives a fire control input, which is programmed, there's a default input for it. We can set it to whatever you want. It ignores, when that input is triggered, it ignores every single fault code that would normally shut down in the case of over current, over voltage, ground fault, whatever the fault would be, it ignores it. So that's what fire mode, how that fits into the drive topology. It's that there are no faults when you're in fire mode. When that input is triggered and set as the fire mode input, it's going to run to destruction. So what's key is that you can run in any scheme you can think of. So you can use what you have already from the fire mode input, or you could use a separate transducer input. You can tell it to run at full speed. You can tell it to reverse direction. You can run it at a fixed speed. There's no limitation as to what you can do. Whatever it is you need to do, you can have the drive do that based on that one single digital input. So the minimum expectation from a VFD is that the outputs are going to be used by the fire control panel. It could be to make control decisions, or maybe not, but the outputs will also appear on that fire control panel. And the good news for you guys in your backyard is that Denver has a more rigorous structure for fire mode outputs than most, but we'll get to that in a minute. Again, a fire input is a dedicated trigger, and whatever you program it to do, it's going to do, and it will run to destruction. So the role of UL 864 in the overall system. So fire control panels, and I don't know the terminology, so I'm not going to spew on that, but it's, I think, endpoint control, something like that. But there's a common request that we get as a manufacturer of drives where people say, hey, is your drive UL 864? And the answer really is no. So yes, the drives do a lot of the heavy lifting in the smoke control, the fire control solution, with the purging of the smoke, controlling the motor speed and the fans. But UL 864 does not apply to motor controls or transducers or any other end device that is simply doing what it's told by the fire control panel. So you won't find a single motor control or VFD that is UL 864 listed. It's not a thing. It makes sense that it could be, but it's not. So just keep that in mind. If someone asks you for that, that's not really something that applies to drives. So smoke control, I mean, as most folks know, if they've looked at this at all, that smoke really causes more damage in the exit of occupants of the building than the fire itself. So maintaining the correct stairwell pressure is very, very critical to allowing occupants to leave and get good air to breathe and have a safe path to exit. You could probably spend an hour or 2 hours explaining the many different scenarios about air handler layout, you know, how you set up these controls, but we don't have an hour and a half, right? So the key is that dampers and drives work together to follow that fire control panel input in combination with the transducers that feed back to do whatever it is you want to do. Again, reverse speed, maintain pressure, run at a set speed, whatever you want to do. For example, one unique characteristic of the Denver Fire Code is a 30 PSI to be able to open the door to get out. But as the event is occurring, right, the door, different doors open, so pressure changes throughout that building, and now you have to adapt. So that's why drives are so critical in that, because they can adjust the speed based on those changing pressures. And you can even have a unique PID loop for the fire control panel. And pressure, so that's what we're maintaining, we're trying to control in a fire situation. And fire creates its own pressure. And when you turn it to steam with water, it creates more pressure. And you're always seeking the lowest pressure. The smoke tries to go there. So it's a very complicated, building specific situation. But whatever it is that, again, you need to do with a drive to manage that, it can be programmed to do that. Typically, most common is having a transducer that is fed back from the stairwell to measure the flow and or the pressure to modulate that speed. So unique to Denver code, which I believe, don't quote me exactly, but I think it's 909.13.2, are some common outputs that are not necessarily always used all the time, but for the Denver fire mode, the drive is required to output back to the control panel, the fire control panel lock rotor, which is an over torque situation. So if the motor shaft is jammed, broken belt, so it's not drawing enough current, says, hey, I'm running at full speed, but I have no torque. That's a problem. Is the drive running? Is it enabled? Is the damper end switch closed? Is the speed being maintained? And is the PI set point being maintained? So it's a total of 7 outputs that are required by the Denver code, which is more than most. So again, we can go through a myriad of examples, but the message that I want to get through today, and we can talk about it, you know, to your heart's content after this meeting, is in any detail you want, but it is possible to configure an HV600 solution that has the 7 outputs. It does require that we have a drive ordered as a bypass, but it expands it to include a IO card, which doesn't allow us to have bypass. So if you need this, you can get it. You just can't have a bypass with it, which is not the end of the world because you never really need bypass anyway. So under torque detection, again, it senses that if the load is less than normal. Over torque, it's a jam situation. And these can be both sent back to the alarm control panel for signaling. And there's practically, I think it's 180 something, but there's probably combinations there within that make it even more. You can have 200 different digital output functions from the HP 600. So I know I'm beating this into the ground, but whatever it is you're trying to do logic wise at that job site to satisfy the code requirements, the HP 600 can do it, assuming that the installation is set up to achieve what you're trying to do. It's kind of like when you have people want to install a new thermostat in their house. It's like, well, that's not going to really help my old HVAC system, my old furnace, because it can't blow more air. So the fancy thermostat's not going to help. But if everything is in place and you use a Yaskawa drive, you can make it work. So the primary benefit, of course, is to smoke purge. Pull the smoke out, get fresh air in, and keep things within the limits. And we covered this before, but again, the fire alarm control panel is the trigger to create this special condition for the drive to operate to run to obstruction. And this is actually our last slide. So it's very critical to correctly size drives. Drives that are undersized won't work well in these situations. You never want to have a 230 volt or a 460 volt situation where you're selecting the wrong drive, obviously. But more importantly, the fan curve is critical to make sure that it works. And again, can't reiterate enough, UL 864 has nothing to do with drives. I'm grateful for that because it makes life easier, but it makes sense that people would think that. But if someone asks you that, that's not really a thing. And again, it's Denver in particular, a very unique market where you could show up to a job site and find out that, hey, something's not working right. The good news is, again, the drive can be programmed to do whatever it is you're trying to do. That's it.
All right, Don. Well, I appreciate that. Just to reiterate the fact that this drive that Yaskawa offers, the HV 600, is Denver fire compliant. We can make sure we've got all the proper outputs needed for this any application. So really appreciate your time today, Don. Thank you for going through everything. We do have some prizes to choose from this week. We've got a gift card, sleeping bag, and a whiskey rum making kit. So today's winner is Mike Ronchek. Mike, feel free to reach out and let you choose your prize. If there are any questions on the presentation, again, reach out to your long representative. We're all very knowledgeable on this product and we can step you through anything that you need. So with that said, thank you very much for joining us today. Enjoy your long weekend, be safe, and look forward to seeing everyone next week while Tyler Martin introduces the Halo sensor. It's an all-in-one sensor for K-12 schools. And thanks again for joining us today. Have a good day.
Thanks, guys. Bye.